Hey, if you collect everything there is in the universe, wow, that'd be a lot of stuff. But what color would it be? It isn't possible to answer that, but we can at least go back in time far enough to see how it looked when it all began to exist. Yes, this is apparently possible. We all know about this mysterious and fascinating moment called the Big Bang, which gave birth to all that we can see around us right now. Now containing red dwarfs, white dwarfs, seven dwarfs, emerald supernovas, blindingly bright quasars, and everything in between, the universe is as colorful as it gets. But of course, it wasn't like that at the time of its birth. It originally had just one color. As it expanded and cooled down, it formed more and more tangible matter and started to morph into all the colors we're used to seeing today. To be able to see through time to the very first moment, 13.8 billion years ago – I wasn't around then – you would need a time machine. But even then, you won't see anything, just black nothing. And it's not like the clocks on your time machine are off. This is the moment the Big Bang is happening. You just can't see it because our eyes are sensitive to photons, and none of them exist at this point. The universe is simply too hot now to allow even something as basic as photons to form. But seconds later, it's already a different story. During these first seconds, the universe is expanding so fast and with such power that the temperature drops by trillions and trillions of degrees before it reaches the end of the first minute of its life. Approximately 14 seconds from the beginning, it's already at 5.5 billion kelvins, and 48 seconds later, it loses another 3.5 billion degrees. If, from the sheer epic of this universal scale, these numbers sound humble to you, well, that's my fault. They're anything but humble. And the best proof of that would be that you can't see anything at all. How is that? Well, photons already exist, in fact, as well as protons and neutrons. Morons, well, we'll talk about some other time. And they're already busy forming the various nuclei of gases like helium and hydrogen. Congratulations, by the way, these gases give us our first forms of tangible matter. And when gas is heated up like that, it'll take the form of plasma. Everything is a blazing plasma right now, and that's bad news for photons because they can't move freely in such extreme environments. And if photons can't move how they want, you won't be able to see anything. To see something, you'll have to wait, and not another minute, but another 380,000 years when the universe cools down. Until then, this epoch in the history of everything is what scientists refer to as the Dark Age. And while our time machine is reconfiguring, let's figure out how scientists even know all this if they don't have a secret time machine like this one. They use a method called cosmic microwave background scanning. That moment, 380,000 years after the initial Big Bang, the universe got so hot that subtle traces of that heat and light still persist in the space around us. They form an imprint, which shows the whole process of the universe's creation. Scientists learned to study this imprint like an ancient map of a world that no longer exists. Fun fact: astronomers figured out that the age of the universe is exactly 13.8 billion years, because they can see this imprint from a distance as huge as 13.8 billion light-years away. But remember, at the time we're talking about, 380,000 years after the Big Bang, the universe was still quite small. That is, if you can call something like 84 million light-years across small. But in comparison, yes, it's 164 times smaller than the universe we know now. And it wasn't all plasma anymore. Finally, photons were given the green light to move wherever they want, and that means that we can see something here. And that something is a colossal blob of blindingly bright light. You wouldn't be able to clearly make out anything, actually, because the color of everything is dictated by the temperature alone. This phenomenon is also sometimes called black body radiation. This radiation is as bright as the matter it irradiates is hot. And the term black body doesn't mean that whatever emits this colorful thermal radiation is necessarily black per se. It means that this irradiating object is unreflective to light, or at least its own appearance, including its color, won't mean much to an observer because of this radiation that obscures everything. To draw a picture of it in your mind, remember how lava looks. Its red, yellow, and orange glow isn't representative of the matter itself, because in places where it's already cooled down, it's ashy black or gray. But of course, you would say that lava is bright in its fiery colors. This is how the whole universe looked back then, 380,000 years after the moment it was born. It looked like fire because the temperature made it look that way. As the universe continued to expand, it also continued to lose the heat. This process is in action to this very day, and scientists say that it won't stop anytime soon. Probably not even until the universe consists of mostly nothingness between celestial bodies, and its temperature will be a tiny bit higher than absolute zero. You can even imagine it like one supernova explosion, so massive that it takes billions of years to happen. And, fascinatingly enough, we happen to live somewhere around the middle of its timeline. With the loss of temperature, the glow of its thermal radiation has gone through several metamorphoses. From blindingly bright yellow, it went to fiery orange and then became red, which was replaced by black. Mostly. These relatively modern times in the life of the universe became the dawn of its spring, and more stars emerged from the cooling matter. They were born from hot gas clouds, and they were aging, cooling, turning orange, and then red as the universe did before. Then the stars were exploding into supernovas with every color imaginable, or collapsing into black holes where no color is possible at all. Fun fact: black holes are what scientists call perfect black bodies, and they emit radiation powerful enough to be seen as a ring of orange heat. If you remember the first photos of a black hole that came out recently, this is what you saw on them in the most basic terms. In some way, asking about the color of the universe during the Big Bang is like asking about the color of a black hole. The first and only visible thing that ever appeared in the universe was so heated that it looked like an orange glow and nothing more. Today, it's another matter completely. There are from 100 billion to 200 billion galaxies around us, and they're all full of motion, so colors are uncountable and ever-changing. When ancient astronomers looked into the skies and saw part of our own galaxy, the Milky Way, they didn't name it this just for kicks. They meant it. It looked as if someone had spilled milk over the dark skies. And one of them thought, "Hey, what a great name for a candy bar." And the other ancient astronomers asked, "What's a candy bar?" Anyway, there's one rough estimation about what color the universe is today. It's well known that our galaxy isn't that dense, and its appearance to us is only what we're limited to from our planet's perspective. Yet this perspective matters because it blurs all stars and all matter in general into something homogeneous. And this is the key to knowing what colors a galaxy, or even the universe, would be if it was just one separate object. And the answer is probably in your cup every morning. This color is cosmic latte, and the analogy between the universe and coffee is a surprisingly good one. Just like a good latte, the universe will get darker with time, and it is the lightest and brightest right after it was made, or appeared in the case of the universe. I'd like a low-fat, no-foam decaf double-shot universe, please, and hold the whip. Hey, if you learned something new today, then give the video a like and share it with a friend. And here are some other cool videos I think you'll enjoy. Just click to the left or right, and remember, stay on the bright side of life.